Yeah, very good afternoon to one and all. And in today class, I'm going to explain about introduction to lexical analysis and the role of lexical analyzer, and then what are the issues that we're having in lexical analyzer. And the next final concept in this session is about an lexical errors. And these are the topics that I'm going to explain in this class. See, just by recalling the last classes that I already explained to you all in the last classes, that is the in unit number 1, up to the last classes what we learned is about the introduction of the compilers and the knowing about what the fundamental concepts of the compilers are, and the main concept that is on various phases of the compilation and how the process of compilation is carried out. These are the concepts that we learned in an last classes that comes under the phase 1 in unit 1, and now we are going the phase 2 part, that is lexical analysis. The name of the second part is an lexical analysis, and here we are learning in detail about knowing about the internal functionality by learning some concepts about the lexical analysis. And before knowing about the role of the lexical analyzer, just I am giving the introduction about the lexical analysis. And here the process of compilation starts with the first phase called as an lexical analysis. As we all know that, where in the last class we already see the example by taking a translation statement as an example, and we already implemented various phases of the compilers, and we know how the object code is going to be generated. We know how to implement the object code, and to implement the object code, what the phases that we implemented there, we used it there. So in that list of phases, the first phase is an lexical analysis phase. So the process of compilation starts with the first phase called as an lexical analysis. And here in this phase, the input is scanned completely in order to identify the token. As we all know, this lexical analyzer can also be called as an scanner. Analyzer can also be called as an scanner. So the input is scanned completely in order to identify the tokens by using this lexical analysis. And the token structure can be recognized with the help of some diagrams. Here the token structure can be recognized with the help of some diagrams, and these diagrams are popularly known as finite automata or finite state machine diagrams. And again, by recalling the finite automata theory subject, what we already learned in the last semester, just by recalling the concepts of what the finite state machine is, how to represent the finite state machine, and what the context free grammar is, and what the regular expression is, and how to convert NFA to DFA, NFA to DFA conversion, and how to draw the or how to represent the NFA with epsilon machine, NFA with epsilon, all these again we are recalling those. We are recalling those in this concept like an lexical analysis. What it means is these what the diagrams, some diagrams are popularly known as finite automata diagrams, and by using these diagrams we are representing the regular expressions. By using these diagrams, we are representing the regular expressions. That means what the meaning that we are having here, while using the finite state machine like an finite automata and taking the input in the form of a regular expression means whatever the diagrams that are popularly known, those diagrams are nothing but an finite automata diagrams. And by using these finite state machines, what we are doing is to construct such finite state machines. What we are going to use is regular expressions as an input. And at the time of explaining the construction tools, there we are having one of the construction tool like an scanner generator. There itself I explain, to implement the scanner generator tool, what the specification that we need, what the specification that we are going to use. The specification is in the form of an regular expression. The specification is in the form of an regular expression. Make a note of this. And to generate the lexical analyzers, the specification should be in the form of an regular expressions. So by using the finite automatas, we are representing the regular expressions, and these, to generate the tokens, to generate the tokens, and these regular expressions are useful for that. To generate the tokens, these regular expressions are useful for that. And then these diagrams can be translated into a program for identifying the tokens. Whatever the diagrams that we are representing in the form of an finite state machines, those are all translated into a program, and these are all useful for identifying the tokens. And that is nothing but an lexical analysis. That is nothing but a lexical analysis. And here in this part, what we are going to learn is, we are knowing about what the role of the lexical analyzer in compilation process, and we are also going to discuss about the methods of identifying the tokens from source program. And as I already said, that we are implementing a tool like an Lex tool in an lexical analyzer. That means in a scanner generator, we are using the tool like an Lex tool that we are taking from the utilities from the Unix. Utility from the Unix, we are implementing an Lex tool. And we will learn a tool like an Lex, and which automates the construction of the lexical analyzers. And this is the brief introduction about the lexical analysis. Briefing out and lexical analysis. And the next is going and internal knowing about the internal functionality of the lexical analysis by seeing the role, by seeing the structure like and role of the lexical analyzer. Role of the lexical analyzer. To describing the question like explain about the role of the lexical analyzer, first you have to draw the structure like this. All of you see the slide once. See the slide, then you can easily understand. Representing the structure like this. This structure is an role of lexical analyzer. This structure describes the role of lexical analyzer. And now I am briefing out the role of lexical analyzer. And the first point, in the first point, I'm going to explain about the role of lexical analyzer is where it is an first phase of the compiler. Lexical analyzer is the first phase of the compiler. And by using the input program, see here the structure consisting of a source program and the lexical analyzer. Here from the lexical analyzer to parser, there is an arrow mark representation, and there we're defining a token, and from parser to analyzer we're having an arrow representation, that there we're having an get next token. And we need not bother about what the parser is, because here we're only learning about the functioning of the lexical analyzer, knowing how the implementation is going in an lexical analyzer, not about the parser. And see here the symbol table where it is one of the subphase of the compiler, and this is acting as an, this is connected to both the lexical analyzer and the parser, where it is acting as an data structure here, maintaining the record of the lexical analyzer and the parser. So there is the connectivity from the both phases, lexical analyzer and the parser. See, what it means is taking the source program. Now what I am doing by implementing the lexical analyzer, I need to scan the program. First initially scanning the input program, then generating the tokens, then generating the tokens. And after generating the tokens, that each and every token is send it to parser. Each and every token is send it to parser. And this parser is having a request that get for next token. Get for next token. It requests the token from the lexical analyzer. The lexical analyzer sends the tokens to the parser. And whatever the things that we done in a lexical analyzer, that means the converting from sequence of characters into sequence of tokens, that the data is stored in a symbol table, and taking the tokens, that means gathering all the tokens from the lexical analyzer is stored in a symbol table from the parser. And see, that's why we're having a connection between the lexical analyzer and the parser for the symbol table. And here we are not implementing, or we are not generating the output of the parser. Directly we are not generating a machine level code. Here only what our concept is about lexical analyzer up to this part. See the cursor that I am showing, up to this part. That means generating the tokens from the lexical analyzer. Up to this part we are going to learn and in detail. Going to learn how it was interacting with this shows that interaction between the lexical analyzer and the parser interaction. Giving the tokens, set tokens, get tokens. That's all. Set token, get token. Just the two functions that are going to be implemented, set token function and the get token function. Between these two, that is the interaction that is made by the both phases. One is lexical and the parser. And now going in detail describing about this structure. Describing about this structure. The first point that we need to describe is the first phase of the compiler. This lexical analyzer is the first phase of the compiler. And the second one is the lexical analyzer reads the input source program from left to right, scanning the input from left to right. For example, just recall the translation statement that we already that I already explained at the concept various phases of compiler. And by taking an example, like in position is equal to initial plus rate into 60. That is the source program. Yes, source program is position is equal to initial plus rate into 60. Now my input string starts from position and ending with 60, ending with the value numeric value 60. That means now I'm scanning from left to right, scanning the input from left to right. That means my arrow is at an position because I'm starting at left and scanning each and every character at a time, not overall input program at a time. We are not performing the scanning operation. What we are doing, taking an position as a character, scanning that position and recognizing that what type of a token it is and naming the token. That's it. And now I take the I read the position as a character, and now I am converting that into a token by giving the name identifier. Now going to the next character is equal to, where is equal to is an assignment operator. Assignment operator is an assignment operator. There is no change in conversion. So assignment is assignment. Now go to the next character. That means I'm scanning the input character by character by doing it in an left to right process, by performing it in an scanning the input from left to right, scanning the input program from left to right, starting from left and ending to right. That means up to when I read an 60, after recognizing the token of that value 60, then the input string in the input buffer ends. That means end of the file. There is no other character to read. I think you all understand. So in a such a manner, what we are doing here is while implementing the lexical analyzer, this lexical analyzer reads the input source program from left to right, one character at a time. From left to right, one character at a time, not overall source, not entire source, one character at a time, and generates the sequence of tokens. And generates the sequence of tokens. This is nothing but the role of the lexical analyzer. This is nothing but the role of the lexical analyzer by showing it in a neat structure. And here each token is an logical cohesive unit. What it means is a token is it may be an identifier, it may be a keyword, it may be an operator, or it may be any other punctuation marks, whatever it may be, we can recognize them as tokens and giving the meaningful name of it. That's it. Just what we are doing here is converting the characters into tokens. And then after the process of this lexical analyzer scanning and generating the tokens, now the parser to determine the syntax of the source program. The parser determines the syntax of the source program. Means can use these tokens. By using these tokens that are generated by the lexical analyzer, this parser determines the abstract parse tree here. That is the output of this parser. Determines the abstract parse tree. Right? I think you all understand what I am saying here. Just briefing out the role of lexical analyzer with a neat structure. And most important points I am describing here, make a note of all those. And after completion of the process of lexical analyzer by generating the tokens, then what the parser will do? Parser is used to determine the syntax of the source program by using the tokens, that are generated by the lexical analyzer. And the role of lexical analyzer is the process of compilation. This is the role of lexical analyzer in the process of compilation. And after, as the lexical analyzer scans the source program to recognize the tokens, it is also called as a scanner. Scans the source program to recognize the tokens is called as an scanner. That is the definition of the scanner. scans the source program to recognize the tokens. It is also called as an scanner. This is done by the lexical analyzer. This is done by the lexical analyzer. And apart from token identification, lexical analyzer also performs some functions. Lexical analyzer also performs some functions. I am explaining those functions. Please, all of you make a note of those. I am explaining the functions. All of you make a note. What the first function, and after I performed the role, I performed the implementation of this lexical analyzer. I implement the tokens. That means I generated the tokens by performing the lexical analyzer phase. Now after performing this, I will define some functions of this lexical analyzers. And what are those functions is, the first one, it always produces a stream of tokens. We all know from the basic definition itself, we know it always produces the stream of tokens or sequence of tokens, whatever it may be. Produces the stream of tokens from the lexical analyzers. And here the main important thing that we should make a note is, always the lexical analyzer eliminates the blank spaces and the comments. Eliminates the blank spaces and the comments. What it means is, for example, if there is any blank space between the character and the character, that type of blank spaces are eliminated by implementing the lexical analyzer. So it eliminates blanks and comments. And it generates a symbol table. See here in the structure itself, it is there. Representation of a symbol table connecting with the two phases. Generates the symbol table which stores the information about identifiers or constants or whatever it may be that are encountered in the input. So here symbol table is an data structure. This symbol table stores the information about all these in the sense about the functions that we performed in an lexical analyzer. About the functions that we performed in an lexical analyzer, all these are stored in an symbol table. And in this lexical analyzer, it keeps track of line numbers. Tracking of the line numbers, we are giving the sequence numbers for each and every line. So it tracks out the line number, and it keep track of the line numbers is done by the lexical analyzer. And this is one of the function where I am explaining for the lexical analyzer. As a function, I am explaining for the lexical analyzer. And what the last function is, always it reports the errors. Always it reports the errors at the phase itself. What it means is, for example, I am implementing a lexical analyzer. Here itself, I can rectify the errors. I can handle the errors by using the error handler. By using the error handler, I can rectify the errors here itself. That means it reports the errors encountered while generating the tokens. Reports the errors and that are encountered while generating the tokens. And finally, how I am explaining this lexical analyzer means, the lexical analyzer works in two phases. The lexical analyzer works in two phases. What are those two phases means? The first phase is an scanner. The second phase is it does the lexical analysis. What it means? It generates the series of tokens. I think you all get the point. What I am doing here is, the working principle of this lexical analyzer is done by two phases. See the cursor. The working principle of this lexical analyzer is done by two phases. What the first phase is, scanning the input program by reading the input characters. Scanning the input program by reading the input characters. And what the second phase is, does the lexical analysis, means it implementing the lexical analysis. What for to implement the lexical analysis? Just to generate the stream of tokens, just to generate the sequence of tokens. To get the output in the form of an tokens, we are implementing this part. We are implementing this phase, that is a lexical analyzer, taking the input from the source program. Taking the input from the source program. See, again I am explaining with an example. See, for example, the source program is take the source program like position is equal to the translation statement that we used for the compilation process, various phases of compilation. There we saw the example with an translation statement. Position is equal to initial plus rate into 60. Now take that as an source here. Taking that as a source. Now performing the lexical analyzer. That means doing lexical analysis. Directly I am not doing the lexical analysis. What I am doing by taking the input like an position is equal to initial plus rate into 60. Now I am scanning that input string, scanning the input program. Scanning the input program from left to right. That is starting from position and ending with 60. Starting from position and ending with 60. Now I am reading the firstmost left character as a position. And now I am reading that position and I am recognizing the name of the character as an token, and I am giving the name for the token is an identifier. Okay, then go for the next. Is equal to is an assignment operator. Okay, is equal to is equal to. Go for the next character. That is an initial. Initial. Again, I'm reading the initial, scanning that initial, recognizing the token for that initial as an identifier. So position is an identifier. Initial is also an identifier. Then initial plus rate, rate, that's rate. Again, rate is an character here. Now we are converting plus. Again, plus is an reading the plus character, plus is an addition operator, same as it is. After converting into an token, the addition operator is an addition operator, no change in that. Again, writing the plus. Now rate, again rate is an character. Now scanning that rate and recognizing the token for that rate as an identifier. Into is a multiplication operator. Now multiplication operator is a multiplication operator, no change in converting between the character and the token for the operators. So again it is a multiplication operator. And 60 is an numeric value. So 60 is an 60, no change in that. So here my input source program is an position is equal to initial plus rate into 60. Now after scanning the input string, and do the lexical analysis, then finally what type of an sequence that I am generating, what type of an tokens that I am generating here? ID1, that means the 1, 2, 3 we are giving the sequence numbers for the identifiers to make difference between the position and the initial and the rate. So I'm separating them with separating those identifiers with by giving with an sequence numbers. ID1 is equal to ID2 plus ID3 into 60. That is the output that we are going to generate by performing this lexical analyzer. And this ID1 is I am after generating an ID1 as a token, that I am passing it to the parser. Then is equal to, it passed to the parser. Then ID2, it passed to the parser, plus passes to the parser. And ID3 passes to the parser. Then into passes to the parser. Then finally 60 passes to the parser. And by gathering all these tokens together, this parser constructs and determines the abstract syntax tree. And for this concept, we need not to bother about the functioning of this part. We need to learn only about this. The bothering only about this part. We need to bother only about this. Just by showing the interaction between the lexical analyzer and the parser, here we're having a representation of the structure like this. Means whatever the tokens that we are generating from the lexical analyzer are sent to the parser. Those are all we are giving to the parser. That's why we are using only two functions here. One is a set function, another one is a get function. Set and get functions are used in between the lexical analyzer and the parser. And that's it. This is the brief description about role of lexical analyzer by knowing what the main important functions of the lexical analyzer. Now going for the next concept, for learning about the next concept. What are the issues in the lexical analyzer? What are the issues in lexical analyzer or analysis? See, here we're having some issues in lexical analysis. just in the last concept in the sense in the role of lexical analyzer, we clearly understand how the process is going to be carried out between the lexical and the parser, and how the lexical analyzer phase is implemented, and how the lexical analyzer phase is implemented, and what type of an output we are taking, and what type of an what type of an input that we are taking, and what type of an output that we are generating. I think you all are clear about that. And now seeing the issues in lexical analysis. See here, there are some reasons for separating the analysis phase of compiling into lexical and parser. And again, I'm recalling what the analysis phase is. This is part one and part two for the compilers. Part one is an analysis and part two is an synthesis. Again, this analysis phase is categorized into three phases. One is an lexical, and the another one is on syntax, and the third one is on semantic. And here we're having an issue like there are several reasons for separating the analysis phase of compiling into lexical and the parser. And what are the most important three reasons are to simple to design the compilers, and making the compilation process in an efficient way, that means whatever the target code that we are generating, that should be an efficient target code. So compiler should be an efficiency. And here compilers portability. These are the three main reasons for separating out these two phases from the lexical analysis, from the analysis phase. And one is an simpler to design, and the another one is an efficiency, which is the most important term. And for this term only, we are doing the process of compilation. For improving the efficiency, we are improving the overall process compilation code. So compilers portability. And here we're having a building tool. We're having two building tools. One is an Lex, and the another one is an YACC Act tool. If you recall the concept in basics of compilers, at the time of learning the basics of compilers, there itself I explained you. We're having various building tools, but here we are using two most important building tools. One is an Lex tool, another one is an YAC tool. These are the two most important building tools. And here specialized tools have been designed for lexical analysis. What the specialized tool that we are going to use here is Lex tool. By using this Lex tool, we can do the automation. We can perform the automation to generate the tokens. So the specialized tools have been designed to help automate the construction of lexical analyzer and the parser when they are separated. In the parser, we are using an ACT tool. In the lexical analyzer, we are using an Lex tool, Lex. These two Lex and ACT are the building tools of the compilers. And these are the most important issues in the lexical analysis. And what are the reasons for separating out the lexical and parser from the analysis phase? These are the three main reasons. And to construct the lexical analyzers, what type of the specialized tools that we are designing here? And that tool is nothing but an Lex tool. And the next concept is about an lexical errors. And while explaining about the lexical analyzer, there I explained about how the functionality is to be performed by the error handler. What type of an functionality is performed by the error handler? So error handler is also connected to the lexical analysis phase. Symbol table is also connected to the lexical analysis phase. And whatever the information that we done, whatever the data that we performed in the lexical analyzers are stored in an symbol tables. And whatever the errors that we handle and that we detect those, rectify those, modify those, and everything information is stored in an error handler. And see here we're having some different errors. For example, the errors that are detected during the lexical analysis phase. What type of an errors are? For example, we can get an spelling errors. For example, we can get an spelling error in lexical analysis phase. Or for example, we can get an incorrect tokens. Incorrect tokens means, for example, the tokens can also be called, we are naming the tokens like a keyword as a token, punctuation mark is a token, operators are the tokens, identifiers are the tokens. And taking an example, now I am reading in position while performing the lexical analysis. I am reading an input like in position. And after reading and after scanning the input, now I want to recognize that which type of token it is. So I'm giving the name of the token is an identifier. In the place of an identifier, if I use an operator, there will get an error. The error like an mismatch. That means incorrect token errors, or some errors like an appearance of illegal characters. These are all can be considered as an default errors of lexical analyzer. We can easily identify those and we can easily rectify those. So, or it may be an exceeding the length of identifiers or exceeding the length of some numeric constants. All these are all comes under the errors of lexical analyzers. We can easily detect those during the implementation of the lexical analysis phase. And see here, nothing we are doing while implementing an process of lexical analysis. What we are doing is just we are converting the sequence of characters into sequence of tokens. That's it. Whatever the in which token that we are converting means, it should be a meaningful token. So whatever the token we are defining there, it should have the meaning. Otherwise, it comes under an incorrect token. And there we'll getting an error like mismatch token. So some default errors we can easily identify those, and we can easily detect those, and we can modify the code and we can update the code, and finally we can generate the stream of tokens. So here see the points here. Once all of you see the slide. As I already explained that, so the having a default error making us to easily understand. So some few errors are the lexical level alone and that means we can easily understand some errors. We can easily identify those errors. Why? Because these lexical analyzers has a very localized view of the source program. Let some other phases of the compiler handle any type of an error, depends on the output that they are going to be generated. For example, here I'm getting a mismatch token. At the time of implementing the intermediate code generator, there itself I will not get the mismatch token error. Why? Because there I'm implementing in 3 address code templates. So the errors regarding the 3 address code template, I will get the errors regarding the 3 address code templates. Whether I am representing in a correct manner or not, whether the representation is having the meaning or not, or whether I use temporary storage, number of temporary storage variables, I used n number of temporary storage variables. Like that, in like that way we are getting an errors. So we can handle the errors at phase by phase level itself. At each and individual phase itself, we are handling those errors. So and the other one is an error recovery. Error recovery is one of the strategy here that we are implementing the error recovery strategy, and it should always be an panic mode errors. And the generated error should be in panic mode errors. See what the final thing is, and after doing all this, after processing the lexical analyzer and after implementing the specialized tools, and finally generating an lexical analyzer output in the form of an tokens, and before generating the output in the form of an tokens, we need to check it out whether any to handle any type of an errors, the default errors, because we all know what the default errors are to be, and checking out the code once, and then After checking out the code and after making the code error free, then only we need to generate the stream of tokens. Then the output, whatever we are executing from the lexical analyzer, is an error free output. That output is taking as an input to the next phase. So make a note of all these. Make a note of all these points, most important points. And in this class, this is about role of an lexical analyzer by describing the lexical analyzer with a neat structure and knowing about the basic functions of the lexical analyzer, and then what the issues in lexical analyzers are, and finally the lexical errors, knowing about the lexical analyzers. And this is the today's concept I delivered to you all. And for the next class, I'm going to explain about what the token is, what the pattern is, what the lexeme is, knowing about the terminologies and definitions of all these, and how to represent the token and how to represent the lexeme, and what we're calling it as in patterns. And by seeing an examples, we clearly understand the concept like lexeme, pattern, and token. And the another most important one is input buffering. Input buffering is the most important concepts, and today next class I'm going to deliver about these two concepts.